Hi, and welcome to Geeks for Geeks. I am Siddharth Hazra, and today we would be discussing number of path. So, let us first discuss the feedback of this problem. The difficulty level of this problem and the expected time complexity is very poorly managed. It is termed as easy, but it kind of demands the high level, like the difficulty level should be hard, not easy. Okay, like it is absolutely very absurd. Okay, so seeing the problem, it kind of seems easy, but the expected time complexity is how much? Big O of M, not N cross M. That makes the difference. So I won't really explain you the test cases because you are not here for the simple solution like recursive one or memoization. You already know that. No, you are not here for it, that. Still, I would just quickly rough down everyone. Like the problem statement tells me that given n cross m matrix, you need to tell the number of ways to reach from 1 1 to n cross m. This is told. There are no hurdles or there no blocked cells, nothing. Simple. Given the number of, like given a matrix, just tell me the number of path. So the intuition, I would talk about intuition because you already know the solution. If your intuition is not clear, like if you have read this problem again and again, then you kind of have learned by heart what is the solution. But what is the intuition? Let us talk about the intuition at first. Okay, so see, basically we are given a matrix. Okay, so if we are given a very small matrix, then the number of ways to reach here and to reach here comes from this and this. Okay, like the number of ways, let's say the number of ways to reach here was 100 and the number of ways to reach here is 90. And the number of ways to reach this part is what? 100 plus 90, that is 190. And the number of ways to reach here is nothing but the sum of this. Let's say this is x and this is y. So this is nothing but x plus y. Okay, fair enough. And we can say the number of ways to reach the source is just one. So we can say that this is nothing but the sum of this and this. Good enough. So this was the intuition. This is how the whole recurrence formula of n minus 1 comma m added to n comma m minus 1 is coming up. This is the intuition. Okay, you draw a very small box. You kind of think, okay, the sum from this and this is coming here, so why not the sum from that and that would be coming here? So let's move forward. So I would just tell you the transition, like how really you would have the intuition, but I would still tell you that this is not very intuitive. Okay, like if you are not a very experienced programmer, you won't really have the intuition. Okay, that's an honest opinion from my side. If you're having the intuition, then you are absolutely very great. Like a person with a medium level of observation won't really have the intuition like me. I didn't really have the intuition. But I would just tell you where I got the hint. So this kind of seemed similar to the problem I have solved earlier of what? Pascal's triangle. Kind of. I have seen this formula before. Okay? I've seen this formula before. Like if you just come here also. Yep, this is good enough. This is a sum from this upwards and this, upwards and this. This is what was Pascal's triangle. So kind of I had a similar idea from Pascal's triangle. Okay. Okay. So to optimize it further, as I was not having any direction, I thought of, like I would tell you my thought process, how I transitioned from this to the solution that we are discussing. So now what was the solution of Pascal's triangle? Because I have solved it earlier. Pascal's triangle can be computed using dynamic programming and binomial coefficient. What? अब ये क्या बला है binomial coefficient? What the heck is this binomial coefficient? Is nothing but NCR, that is combinations. Okay, it is n chooser, the layman's one. Okay, so now I have the intuition. Okay, so let's think about this. Okay, so let's say we have a 4 cross 4 matrix. Okay, 4 cross 4 matrix. This is the source, this is the destination. From the source, we would move to the right. And from the right, I have no other option but to move down. Okay, if I move right and if I move down, I would reach. From here, I can move to down and then I can move to right. And these are the two paths I have. Let's make this a little bit big. Okay, I won't really have all the path, but I would just tell you some of the path. So now, the very first path can be right, right, again right, and then down. Okay, down would come here and then again down, down, down. This is one path I can have. The very next path is I can have some. Okay, let's me just change the color. What I can do is I can come downwards. Okay, this is not the ideal one. I can come downwards. I can come downwards. I can again come downwards. I can again come downwards. I can again go right. Again go right. Okay. Then what I can do is I would again have one more path. That is I would move to right. Then I would move to down. And then I can again move to right. And then I can again move to down. Okay. So if you observe, this is like if you include the source and the destination, that would be absolutely the same one. That is, let's say this is the source, like this would be simply from that point, like source and destination, and this would be again the same thing. Okay, down and right, down and right, down and right. Okay, so let's talk about this. So this looks like this, these all is looking like what you know. Number of strings that can be made of R and D. Number of unique strings. Number of, you don't really need unique strings. Number of strings. Number of count of strings that can be made. Count of strings. Count of different permutations of string. Combination of string. That is made up of R and D. So you just need to count the number of strings that are made up of R and D. Okay, I got the intuition that this is a combination, but how to derive the formula? Okay, how to derive the formula? Clear enough. So if I just have the source and the destination, like this would be source and this would be destination, this would be source and this would be destination, this would be source and this would be destination. This would be same for everyone. Okay. So how many places I have for, like I have number of rows -1. Why? Because this one is blocked. This one is blocked. I didn't visit this one. This one would be same for everyone. This row, this particular value is blocked. Else, other than this, I can select all the particular columns. I can select all the particular columns, and other than this, I can select all the particular rows. So I can select one row less and one column less. The total number of seats I have is n minus 1, n minus 1 and m minus 1, because these are blocked. Like here every time it would be source and destination. Okay, these are the number of places I have. Now what I want to keep, I want to see the number of ways I can keep R and D. Only R and D. Why? Because right and down, these are the only possible ways. So if let's say there is a class, okay, there is a class, and I arrange the seats of all the female, like there are only two types of sex that are present in the class, that is male and female. So if I distribute the class, okay, if I distribute the sitting arrangement of all the females, the leftover sitting arrangement would be taken by the number of males. So if there are only two values, like if I fix one value, the next value would automatically would take up the leftover values. Okay. So I can say the number of ways to arrange either R or either D. That is n. I can either keep n minus 1 or m minus 1. I can do both of them. Okay. Now, here if you observe, like I have the option to choose both. Here if you observe, like I can select either of the combination and the leftover would be taken. If you observe, the value of n is 10 till 10 to the power 9 and the value of m is still 10 to the power 5. Whichever is less, we should be taking that. So this kind of tells me that we should take what? We should take m minus 1 because m is less. So n plus m minus 1 is n plus m minus 2 combination of m minus 1. Okay, this is the value of n and this is the value of r. Now what is the formula of n choose r? N choose r, the formula of n choose r is the value of n is n plus m minus 2. Here I would simply have capital N and the value of r is nothing but m minus 1. The formula of n choose r is what? N factorial divided by r factorial multiplied by n minus r factorial. Seems simple. You can calculate this and return the answer and that would be sufficient enough. But the problem is that this value is very large. So you need to compute it modulo. And that is making all the difference. And that is the position where I consider it a super hard problem. Okay. Okay, so that this looks fine. But the problem is that yes, you can compute the value of till 10 to the power 5 factorial and that would solve the purpose. But the problem is a divided by b modulo m is not a modulo m, b modulo m and whole modulo m. It is that a multiplied by b inverse and then both of them, like it is nothing but like a divided by b can be written as a multiplied by b inverse. So the total value would be a modulo m multiplied by b inverse modulo m and then whole modulo m, and that is making all the difference. The inverse thing is making all the difference. So if you at this point go to the solution, like the given solution, you would see it is using extended Euclidean algorithm, and that is correct. But extended Euclidean algorithm is required when the modulo is not prime. So most of the let us understand the concept of this modulo. The general concept of modulo is that the value won't fit in an integer. That is why they are having it. So compute it using modulo. That is a very rare chance that you would have this in an interview. Unless your interviewer is suspecting that you are not good at doing modulo thing. But you would most of the times encounter this in an online judge. And most of the time, this modulo m, the value of mod, would be a prime number. That is 10 to the power 9 plus 7. Most of the time, this is the value. Okay. So this would be a prime number. if that is a prime number, then we can use a small algorithm, that is Fermat's little theorem. Okay, Fermat's, this is the, you can just see it. You don't really need to see the proof if you're preparing for interviews. If you're preparing for competitive programming, you need to see the proof. Like, you should have the understanding. Else, in a nutshell, you can say that if something, if we have, if we have a modulo to a prime number, what we really can do is to have calculate the value of b inverse. What we really can do is b inverse is nothing but b to the power mod, that is modulo minus 2, b raised to the power modulo minus 2, and this should be the value modulo, and this is the solution. So Fermat's little theorem states that if we have b inverse and it is done by modulo and that is a prime number, then it is b raised to the power prime number minus 2, and we would have the answer. Okay, so a raised to the power b, we need this thing. To compute this effectively, what we really need is fast exponentiation. So if you don't know fast exponentiation, consider learning about. So what are the things associated with this? The things associated with this is, the first prerequisite is Pascal's triangle. Then the next prerequisite is Fermat's little theorem or extended equilibrium algorithm. And the third one is fast exponentiation. So you should know all of this to have the idea of this. That is why I call this problem a hard level problem. Okay, like it summons up everything. So you should know a raised to the power b. So I would implement, like I won't really implement fast exponentiation, I would just use that, and then we would talk about this. So this is the formula we would be implementing: n factorial divided by r factorial n minus r. We would be doing it. Okay, so now let us implement this. The whole magic lies in the implementation. So at this point, just learn. So whenever we want the mod inverse of n, we are just having the power of n raised to the power mod minus 2. Okay, and who is doing the power thing? Power thing is done efficiently by fast exponentiation. Okay, just these two, and then let's come up to this. This is m cross n. Okay, now we would have the initial answer of long answer is equals to 1, because we would add up, and then we would have something like long mod. Okay, let's just have this here itself, comma mod is equals to 1e9 plus 7. You can declare it in the global space too, because that won't change. Now what we would really do is we would go from n to m plus n minus 1. So for, we would just do long everywhere. Long I is equals to n, and I is less than m plus n minus 1. Okay, like these many size of the integers we would have, and then we would have something like I plus plus. At this point we would have something like answer is equals to answer multiplied by what? Answer multiplied by, this is n factorial, so we would compute the factorial at each point. Like we want to go till n, so first it would be 1, then 1 multiplied by 2, then 1 multiplied by 2 multiplied by 3. So at each point we would be multiplying the value of I. Okay, so at each point we would be multiplying the value of I, and we would just keep it as modulo. Okay, after this we would find the inverse and we would implement this one. This thing is done, this is left, so we would first find the inverse and we would do the same thing. Okay, so now we would say long inv, that is inverse, and then we would ask mod inverse What was the mod inverse of what was needed? Mod inverse of what was needed? R and n minus r. So here we would say I minus n plus 1. At each point we are multiplying it, and then comma mod. Okay, and that would be p of I minus 2, and that would be done by default. And then after we have this, we would multiply both of them with a modulo. So an answer is equal to answer multiplied by INV and then whole modulo mod. So you need to do modulo, like modulo was needed at here also, but we are using long to reduce the hard work. Okay, and then we would simply return the value of answer. Now we just compile and run and see how many errors are we making. Seems like no error is being made. That's it. So basically, the a lot of prerequisites were needed to solve up this problem. I couldn't go to the deep root and explain each of the prerequisite. So I did like explain what was the prerequisite at each point, what was the intuition of this, and what is the explanation of this. So this was a list, like this was not a really a tutorial. This was a list of prerequisite that you need to complete and then come back to this tutorial. Then this would look like a real tutorial. That's it for today. Hope you learned all the prerequisites that were needed for this video and then come back to this video. That's it for today. Thank you and have a nice day.